Hi everyone, welcome to my channel. Now in this video I am going to discuss the way you need to study your NCERT textbook. This video have been designed specifically for the students who are going to appear for their board exams in 2020 and also when you are preparing for their entrance exams like JEE, NEET, AIMS and other things. Now no one can deny the importance of NCERT for appearing in board exams or JEE or NEET. Okay, so NCERT book is a book which is not to be neglected. Okay, you can't take the risk of neglecting the NCERT textbook. So now in this video I will try to share my view like how you should read the NCERT textbook so that you don't miss out on the important points, and I'm also going to discuss few of the questions, important questions that you must not miss out for the forthcoming board exams. Now before I start this video, if you are a class 12 students, please take out your class 12 physics book volume 1, chapter number 4, page number 132. Okay, so we are going to discuss moving charges and magnetism. Okay, so now the first page, that is page number 132, that is about the Hoisted Experiment. Okay, that moving charges or currents produce a magnetic field. Okay, that is the last before the last para. Okay, so that statement is given. So this was the observation of Hoisted Experiment. Okay, so this question can be asked like write short notes on Hoisted Experiment. So if it is for 1 mark, this is what you are supposed to write. Okay, now if it is for more than 1 mark, say 2 marks, then you need to draw the diagram, okay, that is given in the other page, and then explain that the magnetic field lines are circular surrounding the current carrying conductor. Okay, and at any point on the magnetic field line, if you draw a tangent, the tangent will give you the direction of magnetic field. Okay, so this is given in the same page, page number 132, that Christian in 1820, Danish physicist Christian Ørsted noticed that a current in a straight wire caused a noticeable deflection in the compass needle. So that is due to the magnetic field of the current carrying conductor. He investigated this phenomena and found that alignment of the needle is tangential to the imaginary circle which has the straight wire as its center. Okay, so that imaginary circle is representing the magnetic field. Okay, and at the center of that circle you have the current carrying wire, and at any point on the circle, if you are drawing the tangent will give you the direction of magnetic field. Okay, so this is your Hoisted Experiment, all about Hoisted Experiment. Okay, then coming to the next page, you have this sources of fields, magnetic field and electric field. That is the fundamental knowledge, that is electric field arises due to charge. Okay, and this magnetic field arises due to a moving charge or a current. Electric field arises due to static charge. Okay, then you have in page number 134, you have magnetic field and Lorentz force. Okay, so equation 4.3 is the expression for Lorentz force. So here the first term QER, that is the force due to electric field, and the second term QV cross B is the force due to magnetic field. Okay, then you need to go through those points in the page 134, page point number 1, that force, magnetic force, they are talking about magnetic force, it depends on QVB. Okay, here Q is different from V and B in the sense V and B are in bold. Okay, so V and B are in bold means in NCERT anything which is in bold, if a physical quantity is given in bold, that means it is in vector form. Okay, so it says that the charge depends on so it says that the force on the charge particle depends on charge, velocity and magnetic field. Velocity and magnetic field are vector, so it depends on the magnitude and direction of velocity and magnitude and direction of magnetic field. Okay, Then it is also given that force on negative charge is opposite to that on a positive charge. This is another important statement. So if the positive charge is experiencing a force in the upward direction, the negative charge will experience a force in the downward direction for the same magnetic field. Okay. Then the magnetic force, it is Q V cross B. Okay, that is force will be in the direction of V cross B. Okay, and the vector product makes the force due to magnetic field vanishes if velocity and magnetic field are parallel or anti-parallel, because F is equal to Q V cross B. So that is VB sin theta. So for theta is equal to 0 degree and 180 degree, this V cross B will be 0. So if the charge particle is moving parallel or anti-parallel to direction of magnetic field, the force will be 0. Okay. Then we have magnetic force is 0 if charge is not moving, that is if V is equal to 0, that is for static charge, the force will be 0. Okay. So these are the fundamental features of this force. Okay. Then just above that blue box, you have this dimensionally, we have B is equal to FQV. Now if B is equal to 1 Tesla, so here they have defined the strength of the magnetic field. Okay. So 1 Tesla is the force experienced by the charged particle when the charge is having 1 coulomb moving with the velocity of 1 meter per second perpendicular to direction of magnetic field, that you can define from the expression B is equal to F by QV. Okay. So definition of 1 Tesla can be asked. So you have to define 1 Tesla from this expression. Okay. Now then we have next topic is magnetic force on a current carrying conductor. This deduction is again very important. F equal to IL cross B. Okay. Then you may be asked you can be asked the derivation of this formula, or you may be asked questions based on this formula. So questions are there in your textbook, it is there in your question bank also, and you should see previous year questions also based on this topic. Okay. One example is also there, example 4.1. Then you have motion in magnetic field, motion of charged particle in magnetic field, page number 137, 138. So here you will read that if the charged particle is moving perpendicular to a magnetic field, it will move in a circular path. In case the charged particle is moving, already we have seen that if the charged particle is moving parallel or anti-parallel to the direction of magnetic field, then the charged particle is not going to experience any force, but otherwise, so if theta is 0 degree or 180 degree, there is no force. If theta is 90 degree, then the force will be such that the charged particle will move in a circular path. And other than that, if the angle is neither 0 degree nor 180 degree nor it is 90 degree, then it is going to move in a helical path. Okay. So you must go through the deduction for calculation of radius, calculation of time period, frequency, angular frequency for both circular motion and as well as helical motion. Now after studying this circular motion part, circular motion of charged particle in magnetic field, you must go through the topic of cyclotron, that is given in page number 140, because mathematical deduction is same for both. Okay. Now regarding cyclotron, so cyclotron, what is cyclotron? It is a device to accelerate charged particle. Okay. Now it has, if you can see figure 4.8, page number 141. So if you have in this cyclotron, you have two hollow Ds. Okay, hollow Ds, and the Ds are evacuated. Okay. Now you may be asked why the Ds are evacuated. So Ds are evacuated so that, see, we are going to accelerate the charged particle inside the Ds. So if the charged particle undergo collision with other particles which are inside the D, then the whole process will stop. So these Ds are evacuated so that there is no collision between the charged particle and the particles which are inside the D. Okay. So the other thing is how to construct this cyclotron. So for construction, you have two Ds, and above the Ds and below the Ds there are strong electromagnets. So these electromagnets produce a transverse magnetic field. So this magnetic field is so adjusted that it is only confined in the Ds. So magnetic field will be there only in the Ds. Okay. Then across the D, if you see below the figure, there is an oscillator. So this oscillator is connected across the two Ds. So this, what does this oscillator does? See, it changes the potential across the two Ds for a particular interval of time. If the left D is having positive potential and the right D is having a negative potential, then when that time elapses, the potential changes. Right D will have positive potential and the left D will have negative potential, and this potential keeps on changing after a fixed interval of time. Okay. Now, what is the purpose of this having this potential difference is, this potential difference creates a electric field in the region between the two Ds. Okay. So, and what is the function of this electric field? If they ask what is the function of electric field in a cyclotron, so the function of this electric field is to accelerate the charged particle. Okay. It is the electric field which increases the kinetic energy of the charged particle. Okay. The cyclotron, we have to accelerate the charged particle and increase their kinetic energy. Okay. But we know that magnetic field cannot increase the kinetic energy. Why? Because magnetic field cannot do any work. Okay. Why it cannot do any work? Because here this magnetic Lorentz force is perpendicular to the direction of velocity. So, since it is perpendicular to direction of velocity, magnetic force is perpendicular to direction of displacement. So, since force is directly perpendicular to displacement, work done by the force is, since force is perpendicular to the displacement, work done by this force is 0. So, since work done is 0, change in kinetic energy is also 0. Okay. So, magnetic field is not going to increase the kinetic energy, it is the electric field which is going to increase the kinetic energy of the charged particle. Okay. Derivation of time period, derivation of velocity, derivation of kinetic energy is similar to what you will read in circular motion of the charged particle. Cyclotron frequency, that term you need to derive. Okay, and then you need to write this is cyclotron frequency, and you will find that expression for time period, expression for cyclotron frequency, it is a constant. Okay. So, if you see equation 4.10, below that it is written, the operation of cyclotron is based on the fact that time of one revolution of an ion is independent of its speed or radius of the orbit. Okay. So, this is the working principle of the cyclotron. Okay. Then you may be asked, like, what are the applications of cyclotron? So, in the next page, page number 142, it is given that it is used to implant ions, it is used to accelerate charged particle, to initiate nuclear reactions. It is also used in hospitals. Okay. So, these are the applications. Now, you may be asked, like, why cyclotron is not suitable for accelerating light particles like electrons, positrons. Okay. The reason is, see, the cyclotron, you have this revolving particle and they are revolving with a particular frequency, and then you have an oscillator which is also adjusted at a particular frequency. Okay. Now, this frequency of the oscillator, the frequency at which the polarity keeps changing, and the frequency of revolution of the charged particle is same. Okay. And this frequency of revolution of the charged particle, we are assuming it to be constant. Okay. Because time period is constant, frequency is qb by twice pi m. So, if this qb, q is the charge, b is the strength of magnetic field, m is the mass of the particle. So, all these terms are constant. So, we are assuming that frequency is constant. Now, if the particle is light particle, it is quickly going to acquire very high velocity. Now, if the velocity is quite high, then what will happen? The particle will undergo relativistic variation of mass. At high velocity, the mass changes. So, if mass changes, the frequency will change. Now, if the frequency changes, this frequency will not match with the frequency of the oscillator. So, in that case, resonance will not be attained and the cyclotron will not work. Okay. So, these are the basic concepts behind cyclotron. So, you may be asked a long answer type question or long answer type question of 5 marks, or maybe some 2 or 3 marks question based on some reasoning. Okay. Then you have the topic of velocity selector, okay, which is used to select particles with particular velocity. So, must go through that topic. And then what are the applications of velocity selector? So, it was used by J.J. Thomson to determine the specific charge of electron. It is also used in mass spectrograph. So, it is written in the paragraph just above the topic of cyclotron. Okay. Then you have Biot-Savart's law, deduction of the Biot-Savart's law. Then comparison, page number 143, you have the comparison between this Biot-Savart's law and Coulomb's law. Okay. So, both are long range force. Electrostatic field is produced by charge, which is a scalar quantity. Magnetic field is produced by ideal current element, which is a vector quantity. Okay. Electrostatic field is along the displacement vector joining the source and the field point. Okay, but magnetic field is perpendicular to the plane containing the displacement vector. So this is one major difference. There is angle dependence in Biot-Savart's law. In electrostatic there is no angle dependence. Okay, so these are some of the important informations. Then this epsilon naught and mu naught relation, how it is related to velocity of light in free space or vacuum. Then this reduction magnetic field on the axis of a circular coil. Okay, and how this reduces to the magnetic field at the center of the coil. Okay, and then after doing this topic, you should additionally try out this example, one exercise question, page number 170, 4.16, Helmholtz coil. So you must try 4.16 A and B part. Okay, B part has been asked in board exam before. Then coming to the next topic, Amperes Circuit Law. This is another important topic, proof of Amperes Circuit Law. Okay, then applications of Amperes Circuit Law, that is magnetic field due to a cylindrical solid current carrying wire, a hollow current carrying wire, graph for variation of magnetic field with distance. Okay, that is given in page number 150, 151. Then using Amperes Circuit Law, how to find the magnetic field due to a solenoid. What are the important features of a solenoid, ideal solenoid. Then magnetic field produced by toroid. Okay. Then this question have been asked many times, very most important question. Page number 154, force between two parallel current carrying conductors and how to define 1 ampere. Okay. So definition of 1 ampere is given in below, just below 4.25, equation 4.25, page number 155. The ampere is the value of that steady current. Okay, this definition. So this derivation and this definition of ampere is very important. Then you have page number 157, torque on current loop and magnetic dipole. So how a current loop behaves like a magnetic dipole, I have made one video also, just previously I have uploaded that video. Then expression for torque. Okay, then from the expression for torque you must additionally calculate how to find potential energy and relate the position of stable equilibrium and unstable equilibrium. This is similar to what you have studied in electrostatics, expression for torque, potential energy. There also you had electric dipole in electric field. Here you have magnetic dipole in magnetic field. But we have calculated the potential energy and stable equilibrium and unstable equilibrium in electrostatics, that electric dipole also. Okay. Then you have this current loop as magnetic dipole, comparison of the expression for electric field and magnetic field, magnetic dipole moment of revolving electron, page number 162, evaluation of Bohr magneton, that is magnetic moment of the first Bohr orbit, that is equation 4.37. Okay. Then another important, very important topic, moving coil galvanometer. So working of moving coil galvanometer, what is the significance of the radial magnetic field? Okay. How can you convert this galvanometer into ammeter, galvanometer into voltmeter? What do you mean by current sensitivity? So those things are given in italics itself. Current sensitivity, voltage sensitivity, page number 165. Then another important question that may be asked, like galvanometer we are detecting current, but then why it is not used to measure current, like why it is not used as an ammeter? Why do we need an ammeter separately? Okay, so for that the answer is given in page number 164, the second last para. A galvanometer cannot as such be used as an ammeter to measure the value of current. And what are the reasons? Galvanometer is a very sensitive device. It gives full scale deflection for a current of the order of microampere. It is giving full deflection for even for microampere current. So then how will we be able to measure 1 ampere current or 2 ampere current? So that is why it is not suitable. Then other thing is, like for measurement of current, galvanometer has to be connected in series. Okay, for measuring current you will be connecting the galvanometer in series, but galvanometer is a high resistance device. We need a low resistance device to measure current. Okay, so that is, it is for these two reasons it is not suitable for measuring electric current. Okay, so this is how you should read your NCERT textbook so that you should not miss out anything. Now in this video I have discussed only the theory part and I have not discussed the other questions like which are given in the NCERT, because my view is like you should not miss out any questions from the NCERT, because already they have given only few questions, and from that also if you neglect those questions then it will not be helpful. You may get marks in board examination, but then you may face trouble in your JEE or NEET. Okay, so you must go through all the solved examples as well as the exercise questions. Okay, so I hope this video is of some benefit to you. In case it is beneficial, do share this video and also post your comments about other chapters also, so that we can discuss those chapters together. You will sit in your house with your NCERT and I will sit here and then we will discuss. My best wishes to you. Good luck.